So, have you ever stopped and wondered how we really know if a new idea is better than an old one? I mean, how do we use actual data to challenge something everyone just assumes is true? Well, there's actually a formal process for this, and believe it or not, it works a whole lot like a courtroom drama. Let's dive in.
Here's how we're going to break down this data-driven trial. First, we'll start with that core principle, innocent until proven guilty. Then we'll meet the two competing stories at the heart of every case. After that, we'll walk through the 5 key steps of the trial itself. Look at what happens when the verdict gets it wrong. And finally, we'll talk about why this whole process is so critical for making smart decisions in the real world.
All right, let's officially step into our courtroom for data. The first thing we have to get our heads around is the foundation of any fair trial. And you know what? Statistics is no different. This whole thing is built to be a structured, fair way to weigh evidence. And it all starts with one crucial assumption.
This really is the million-dollar question, isn't it? Whether you're in science or business or medicine, people are making new claims all the time. But here's the thing. A claim is just an opinion until you have the evidence to back it up. And that's where statistics comes in. It gives us the rule book for putting that claim on trial.
The starting point here is absolutely key. Just like in a legal system, the established belief, the way things are, the status quo, it's automatically presumed to be true. It's our defendant, and it's considered innocent right up until the moment the evidence proves otherwise.
Okay, so if the status quo is our defendant, then every good trial needs a prosecutor, right? Someone with a totally different story. In statistics, we call these competing stories our hypotheses. They are the two opposing ideas that we're about to present to the jury, which in our case is the data.
So on one side, you have the null hypothesis. You'll see it written as H0. Think of this as our defendant. It's the existing theory, the world as we know it. Then on the other side, you've got the alternative hypothesis, or H1. This is the new kid on the block, the prosecutor's big case, arguing that, hey, maybe the status quo was wrong.
And this slide just lays it all out perfectly. The null hypothesis is the innocent defendant, the one that's assumed to be true from the get-go. The alternative hypothesis, that's the prosecutor. It's the new claim and, this is important, it carries the burden of proof. It has to come in with some seriously convincing evidence to win the day.
Now, this is a super important point, so let's pause on it. We never, ever prove the defendant is innocent. Think about a real court verdict. It's either guilty or not guilty. Not guilty doesn't mean we know for a fact the person is innocent. It just means the prosecutor didn't have enough evidence. It is exactly the same here. We either have enough data to say guilty and reject the null, or we don't.
Okay, so we've got our defendant and we've got our prosecutor. Now it is time for the trial to begin. And this isn't just some free-for-all. Hypothesis testing follows a really clear 5-step procedure to make sure everything is handled fairly and that the final verdict is solid.
It goes like this. First, you state your hypotheses. Basically, what are the innocent and guilty claims? Second, you decide on the standard of proof. How strong does the evidence really need to be? Third, you define exactly what that overwhelming evidence would look like. Fourth, you go out and get your data and analyze it. And finally, step 5, you deliver the verdict.
I know this chart looks a little technical, but hang with me. The idea is actually pretty simple. Don't worry about all the symbols. Just look at that bell curve. And see that little shaded area on the far right? That's called the rejection region. You can think of it as the statistical version of beyond a reasonable doubt. If the evidence we collect is so rare, so far out that it lands in that little zone, well then we've got enough proof to declare the defendant guilty.
So after all that, the judge bangs the gavel, and there are only 2 possible outcomes. We either reject the null hypothesis, which is our big guilty verdict. We've got strong evidence for the new claim. Or we fail to reject the null hypothesis. That's our not guilty. The evidence just wasn't strong enough to kick the old theory out.
But, just like in a real-world trial, the system isn't perfect. Juries can make mistakes, and so can our statistical tests. And there are 2 very specific kinds of errors that we need to watch out for.
So the first one is called a type 1 error. In our courtroom analogy, this is the big one, convicting an innocent person. It happens when our data, maybe just by pure random chance, looks so convincing that we reject the null hypothesis, even though the null was actually true all along. Ouch!
And here's a perfect real-world example, a false positive. The test tells you that you have coronavirus. It's rejecting the innocent or null idea that you're healthy, but in reality, you don't. That test just made a type 1 error.
Now, the second kind of mistake is a type 2 error. This is the complete opposite scenario. This is when the old theory, the null hypothesis, is actually false, but our evidence just isn't strong enough to prove it. In court, this is letting a guilty person walk free.
And that brings us right to the false negative. The test says you're perfectly fine, it's failing to reject the null, but you actually do have coronavirus. And you can see how the consequences of this kind of error could be really, really serious, right? It lets a harmful condition just fly under the radar.
So after all this, a courtroom for data, statistical errors, why should you care? Why go through all this trouble? Well, because this whole process is basically the engine that drives progress and smart decision-making.
And this isn't just some abstract theory either. What you're seeing here is data from a real experiment. Engineers were testing if changing the temperature affects the strength of ductile iron. They use hypothesis testing to make critical decisions about safety and materials based on data just like this. This stuff is happening everywhere, all the time, behind the scenes. Just think about it. Is a new medicine really more effective than a sugar pill? Is that new website design we launched actually getting more clicks? Did that tiny change on the assembly line actually improve the product? All of these are claims. They're alternative hypotheses, and they need to be put on trial. This is the framework we use to get real answers.
So, now you've got the toolkit. You see how data can be used to challenge the status quo in a structured, evidence-based way. Which kind of leaves us with one last fun question to think about. What existing theory, what common belief in your world, in your job, or your life would you want to put on trial? What evidence would you need to gather to make your case?